Okay, this video is over ions, what they are, and then how ions form. Alright, so the first thing we'll look at here is what exactly is a bond. And you should know this from the previous video, but we're going to write it down again to make sure that you do. Okay, a bond is just the force that holds two atoms together. Now let's remember, when we look at bonding, okay, valence electrons are the ones that are involved in bonding. So we're not talking about those core electrons. We're talking instead about the valence electrons. Remember, valence electrons are the electrons that are in the outermost energy level. Those are the ones that are in the S and P groups. We don't really count the D groups as valence electrons. So when we look at bonding, okay, there are two types of bond attractions. And the first type is the attraction between a positive nucleus and then the negative electron of another. So we're talking about the attraction between two subatomic particles. Okay, the electron and then the positive proton in the nucleus. The other type of attraction that will make a bond is the attraction between positive and negative ions. Notice how they're both opposites though. Okay, it's a positive and a negative something. And we're going to continue to look at these two types of bond attractions throughout the next two chapters. Okay. Well, when we start to look then at how things bond, okay, we have to figure out exactly how many valence electrons something has. So let's review a little bit, okay? Let's look at the noble gas notation for magnesium. Okay, you can write it out if you want to, or you can just look at your periodic table. If I was going to write it out, magnesium there is number 12. Okay, so I would put neon in brackets, and I would go 3s2. So how many valence electrons does magnesium have? 2. Okay. And remember, these are the core electrons that do not want to be lost. They are part of a stable configuration. These two are very easily lost because magnesium would like to have a noble gas notation. How about if we look at calcium? Okay. Calcium would have argon in brackets and then 4s2. How many valence electrons does it have? 2. Okay. When we look at those two, we notice that magnesium and calcium are in the same group. You should have looked at this last chapter, but elements that are in the same group have the same number of valence electrons. We look at sulfur. Put neon in brackets, and we're going to go 3s2, 3p4. So sulfur has 4 plus 2. Sulfur has 6 electrons. Notice how it is in group 16. Group 16, 6 valence electrons. And the other question is, what is the highest number of valence electrons an atom can have? Well, remember we talked about noble gases being stable. When we look at where noble gases are situated, okay, if I'm going to say, right, for example, neon in bracket, or neon, I would put helium in brackets, and I would do 2s2, 2p6. So these guys have 8 valence electrons. That is the highest number that you can have. Okay. So looking at all these valence electrons and their number of valence electrons, we then can start to write what are called electron dot structures. Because all I care about in bonding is the number of valence electrons, because those are the things that are involved in bonding. So electron dot structures only show valence electrons. These are the only ones involved in bonding. And just like we were looking at, they are after whatever is in brackets, okay? Those are the valence electrons. The group in S and P tell you the valence electron number. So something in group 14, like carbon, okay, carbon's in group 14, it has 4 valence electrons. Magnesium is in group 2, it has 2 valence electrons. Now what about something in the D block? D block ones can get a little bit dicey. They can actually have different numbers of electrons they can lose, but most things in the D block have 2 valence electrons from their S group that is right in front of them. But not always. Something like vanadium can actually lose 5 or 6 electrons, so it really just kind of depends as to what they are reacting with and which transition metal you are looking at. Okay. But the ones in the representative groups, okay, the S and P block, will have whatever their group number is. So when we start to look at electron dot structures, we look at what this table has right here. Okay. And when we look at this table, we see the group number and a representative element from each group. Okay. Notice how in group 1 we have 1 valence electron and lithium has 1 dot. Beryllium in group 2 has 2 valence electrons, 2 dots. 3, 4, 5, 6, 7, 8. Now what you'll notice about these in the dots is that there is 1 on each side, like in carbon, before we put 2 on a side. Now I don't care which direction you put these dots, okay, as long as you have 1 on each side before you have 2 on a side. So if I want to look at, say, beryllium, okay, it has it on 1 on either side. You could also have it here, okay. I could also say that beryllium has these 2, okay, or any combination. I don't care as long as beryllium has 2 and they're not on the same side. So I could not put this. That doesn't work, and you'll see why later. All right, but there's some we're going to look at what is called the Octet Rule, and that goes along with our noble gases, okay? Like I said before, the noble gas configurations are the stable configurations. So these are the ones that have 8 octet. The noble gases are always stable with 8 electrons. We call that our octet rule. For right now, compounds will form so the atoms have 8 electrons around them. They're either going to lose electrons, gain electrons, or share electrons. That is the octet rule. Atoms like to have 8 electrons around them. It gives them a stable configuration. Alright, so we're going to practice now and write some electron dot notations. So we find potassium. Okay, potassium is K. Now look at what group it's in. Potassium is in group 1, which means that it has 1 dot by it, or 1 valence electron. Then I move on to phosphorus. Phosphorus is P. So now I say, okay, phosphorus is in group 15. It's the 5th one over in row 3. So I have 5. 1, 2, 3, 4, 5. 5 valence electrons. Now if you had 2 dots on the right side or 2 on the bottom, 2 on the left, it doesn't matter. As long as you've got a total of 5 and 1 on each side before we have 2 on a side. Now look at bromine. Bromine is Br. It is in group 17, which means it has 7 valence electrons. So now I'm going to go, okay, 1, 2, 3, 4, 5, 6, 7. Okay, now I know that there should be 8, so I know that I'm going to have one side that's empty. So I can go ahead and fill in 2 at a time. If you don't know that right off the top of your head, that's fine. Just go 1 and 2 on the other side, 3 on the bottom, 4, 5, 6, 7. Okay. All right, aluminum. Aluminum has 3 valence electrons. It's in group 13, so I go 1, 2, 3. And those are electron dot notations. Now we're going to look at how ionic bonds form. Let's review a little bit, okay? We look at nonmetals. Nonmetals form what kind of ion? Remember, nonmetals are on the right side of the table. They want to become like a noble gas, so they're going to gain electrons, which means they're going to become an anion, or negative. Metals then want to lose electrons to look like a noble gas. We call those cations, and they are positive. So oxygen will gain how many electrons and form what type of ion? Oxygen is in group 16. It needs to gain 2 more to look like a noble gas. I'm going to gain 2, so that would be a 2 minus, call that an anion. So keeping that in mind, let's look at how these form. Okay, an ionic bond is the force that holds 2 oppositely charged ions together. Remember I said there were 2 types of bond attractions, ones that are positive and negative ions, ones that are positive protons and negative electrons. The ionic bond one is the ions. Think ionic, ion, okay? You need to have a metal and a nonmetal to be an ionic bond, okay? The nonmetal, remember like I just said a second ago, is the one that gains the electron. The metal is the one that loses the electron. One loses, the other gains. So if we take a look there at the picture that's on the right of your notes, okay? Sodium's on the left side of the table. It is the metal. Chlorine is on the right side. It's the nonmetal. Sodium has 1 valence electron, and it's 3s here. And then it's going to give or lose its 1 electron to chlorine. Because chlorine only needs to gain 1 more to look like a noble gas. So chlorine gains the 1, has its octet. Sodium loses it. It goes back to having an octet. And now we have a sodium chloride. So you'll often see Na with a little dot next to it and an arrow showing that it is losing its electron to chlorine. We end up then with an overall sodium being positive and chlorine being negative, and they're going to bond together. We'll look at what the structure looks like of that later. All right, if we look at then what are called binary compounds. Think binary means 2, okay? So these are ones that contain only 2 different elements. Remember though, it's an ionic compound. Like I was saying there a second ago, one loses and the other gains. We have examples of things like NaCl, MgO. Okay, Na is the metal, Cl is the nonmetal, Mg is the metal, O is the nonmetal. So we look at these ionic bonding. Okay, let's take, for example, calcium and fluorine. So I look at Ca. Okay, Ca is in group 2. I have 2 valence electrons. Fluorine is in group 17. I have 7. Okay, so calcium is going to lose its 1 electron to fluorine. Fluorine's happy, but now I still have 1 extra electron that calcium wants to give away. So what happens? Well, another fluorine comes along. 1, 2, 3, 4, 5, 6, because there's 7. It's in group 17. 7. And then it gives its other electron up to another fluorine. Now calcium's lost its 2. Each fluorine has gained 1 for a total of 2. So I have 2 lost electrons, and I have 2 gained electrons. So my total is 0. 2 are lost, 2 are gained. We look at a formula here. We put CaF2. We have 2 fluorines and 1 calcium. So let's go ahead here and try the last 3 examples, showing how an ionic compound will form between the following compounds and what would the neutral formula be. So I've got sodium and nitrogen. Okay, I've got Na, which just has 1, and I've got N, which has 5, group 15. Sodium's going to lose 1. We need another sodium to come along and lose its 1. We need another sodium to come along and lose its 1. And net with Na3N. Okay, lithium and oxygen. Li has 1. O has 6. 1 lithium. We need another lithium then to come along. And with Li2O. Let me look at the last one. Strontium and fluorine. You have Sr, which has 2. Fluorine, which has 7. Lose 1. And another fluorine. And you have 2. SrF2. And that's it for how ions are formed.